Today we're looking at parabolas when the a value is between 0 and 1. And we're starting by looking at our parent function, the baseline parabola that we compare all others to, y is equal to x squared. That's in red on the screen in front of you. And we're going to go ahead and look at our second blue parabola here, which has a slider for our a value. So I'm going to go ahead and slide it up so it'll increase. And this will remind us of what happens when our a value is greater than 1. It gives us a parabola which you can think of as being more narrow than our parent function, which is shown in red. And that is because when our parabola has an a greater than 1, it is a vertical stretch. And a vertical stretch, I like to imagine it's like you sort of pull the parabola upward. And when you pull it upward, the result is that it has to get closer to our y-axis, our vertical axis, because it's being pulled outward away from the origin, but it's stuck there. So all it can do is stretch out that way rather than move upward. So that's sort of the way I like to imagine the vertical stretch. But on the other hand, when our a is between 0 and 1, I should say, we'll be learning about when a is less than 0 in another video. But when our a is between 0 and 1, this is a vertical shrink. What's currently shown on the screen is a vertical stretch of a factor of 2. But let's go ahead and look at a vertical shrink by sliding this down so our values are below 1. Probably unsurprisingly, our parabola just gets more and more wide as opposed to more and more narrow. And oftentimes the way I like to imagine the vertical shrink is it's like it's compressing the parabola. It's pushing down on the parabola by the factor of a. In this case, this is a vertical shrink of a factor of 0.1. And one thing I'll go ahead and mention is the reason why we're not going to talk about when a is equal to 0 is because a is equal to 0 is not an interesting case. It gives us a line, and we're trying to focus on parabolas, which have this like sort of U shape, as you can see on your screen here. So a is equal to 0 is not a very interesting case. So one thing we need to do is we need to figure out how are we going to graph this. And in truth, we can still apply our 1, 3, 5 rule. It's just that we have a different a value, and it's still going to get us to the same place. So we're going to go ahead and look at the parabola y is equal to 0.2 x to the 5th. Or if you wanted to think of it in another way, y is equal to 1/5 x squared. So we're going to apply our 1, 3, 5 rule and see if it still works. And of course, it is going to end up working, because that's why we're teaching you this rule, because it will always end up working. So we're going to multiply it by our a value, which is 0.2. So 1 times 0.2 is 0.2. And if we look at our parabola, we'll find that if we go over 1 and up 0.2, which is 1/5 of the way up, aka one of these 5 boxes, we do in fact have our point there. Likewise, we have our point on the other side. If we multiply our 3 by our 0.2, we end up with a 0.6. So we need to move over 1 and up 0.6, which would be 3 boxes. 1, 2, 3. Well, there's our next point. Finally, if we multiply 5 by 0.2, 20% of 5 is actually 1. So we need to move 1 over and 1 up, which is 5 boxes in either direction. And we have another point, which lies in our parabola. So our 1, 3, 5 rule, when you're graphing this by hand, will continue to work, as can be seen here, because when we used our a is equal to 0.2, it ended up being on our graph that was generated for us by Desmos. Now, the rest of the properties of our parabola when our a value is between 0 and 1 is not actually different from the properties of the parabola when the a value is 1 or is greater than 1. Our axis of symmetry for this type of parabola remains the same. It's x is equal to 0. If we wanted to talk about increasing versus decreasing, that is also the same. So the yellow part over here, this is our decreasing part. You can imagine the marble rolling down. It's going downhill here. And then at our parabola, vertex down here, which is also still in the same spot. On the other side, in let's choose a different color, in blue, it starts to go up again. And the other thing, of course, I wanted to mention is that our vertex is still 0, 0. So basically everything that we have had and we have experienced with our parabolas thus far applies to our parabolas when our a value is between 0 and 1. The only significant differences are that it now is now wider than the ones that we've worked with before. It's wider than our parent function. And we refer to the transformation, which has changed it, into a vertical shrink. So before we learned about vertical stretches when our a was greater than 1, now we have a vertical shrink that causes us to have a wider parabola. Our 1-3-5 rule still applies. It still has the same increasing, decreasing areas, and our vertex is even unchanged, as is the axis of symmetry. So in our next video, we're going to be finally looking at examples when our a value is less than 0, and that will introduce some additional complications for us.